Okay, so coming to the last part of the video, which is the whole architecture of the uh, application, why we choose this. So this is the core architecture that we have chose. So the browser connects via HTTP for normal request and WebSockets for real time, and the fast API then routes the and the WebSocket routes the request to the message broker, which is the central router, and both messages would be sent to the this broker, like the fast API routes or the WebSockets. Both knows the message broker, nothing else. And then the message broker would communicate with the agents, which is the user agent, the document agent, and the version agent. And then the agents can communicate with database, so database doesn't know the broker, the agents doesn't know that what is the request, the agent knows the broker, the and or also the HTTP and the WebSockets knows the broker. So the broker is the only communicator in between here. So coming to the agent base, if we come here and we see at the line here, so we can see that each and everything has these things, like the message queue. There would be the name of uh, uh, for that. There would be the handlers, and like what are the handlers for each of the agents. So each agent has a name, has a message queue, has handlers, and has running task and the message broker. So each agent have these things. And if we see here, so we can register all of the handlers there, and we can see that the message type would be getting those handlers. And after that, the register handler m- here creates a routing table when an agent says register handler, and that is user login or handle login. It says when I receive a user login message, call my handle login method. So that how it works. And if we see here that what I just said about is if that is running, like this is one of the main part that we are saying, that this is the message processing loop, the agent brain. It waits for a message in the queue, finds the correct handler based on the message type, and calls the handler, sends, and then sends the response back to the broker. This loop runs continuously while the agent is active. That how it works. And then here is another part, which is that what these are one of the main things, that every message has a type, that what operation we want. Is that login, is that document creation, is that version revert thing, or what is that? Then the sender, who sends it, and then the recipient, who should receive it, and then the payload, that what is all of the payload that has with that message, and then the ID for unique identification, and then the correlation ID. Then comes the message broker, which uh, in the message broker, we can start from here, that uh, it is that instance. This is one of the broker uses the singleton pattern. Only one instance exists. Every part of the system shares the same broker. So if we come here and see to it that we want to register the agent here, and this is one of the part of for the code, that when an agent register, it's added to the agent registry. The broker reference is injected into the agent. This is dependency injection, and the agent's capability are recorded, so the broker knows who handles what. That is pretty clear there. And then if we come to this part, which is the recipient, to broadcast the message. So the routing logic, if the recipient is specified and exists, deliver directly. Otherwise, find an agent that handles this message type. So why this design? The API doesn't need to know which agent handles what. That's the reason for this design. And it just sends a message with a type, and the broker figures out goes. Then comes the event bus, which is here, and we can start from, I guess, here. Yep, the subscribe. And how it works, that this component can, we can subscribe to a component with a specific event type. When an event is published, all publishers are notified about that event. And we can see here that how that publishing works. So when an agent publishes events, we would first find all of the subscriber for this event type, find all subscriber for this document, and call each callback. So the WebSocket manager subscribe to the events and broadcast them to connected browsers. This is how the real-time updates work. And then comes the one last file, which is the main file. And here we can see that from here we set the initialized and creates the tables if that those don't exist, and creates the message broker, the central router, and we create all three agents: user, document, versions, user, document, and version agents, and we register agents with the broker. So and we begin their messages processing loops. And it creates the WebSocket manager for real-time connections. So this is how it works. And here we have the, yep, this one was here. All of the application runs here. We set all of these things, and before, like, this is the starting point, and then yields, this is the running point, and when we close the application, this is how it closes. And all of these things are like the cores, and what should we allow, what should not. This is for the HTTP request, it should be starting with the API. This is the prefix, and all of these things others. And the WebSocket should be starting with WS, which is the WebSocket. And we can see the whole process here, that the browser would send, we can create, let's discuss one of the flow for the creation of the document. We click the create document, browser send the post API, the post request to the API documents. Then the fast API route creates agent message, which is the document creation. So this is one of the message the document create. We saw that in the last videos. And then the message broker gets that message that this is for the document agent, and the document agent creates the document in database. And then the document agent send the version create to broker, that this is the version for this specific document. And then the broker routes to the version agent, and then the version agent creates version 1, which is the initial creation of the document. Then the document agent published the document created event, which is in the events there in the core logic, and the event bus notifies WebSocket manager, and then the WebSocket broadcasts all to the connected users, and then we get the response returns to the browser via the message broker. So this is one of the let's say request response for the document creation. So this is how the system is working. Thank you.